Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about small modular reactors that are getting a lot of love because of AI hypercluster needs. So let's dive deep into it. What the hell is going on? So why exactly now? Because again, this idea of small modular reactor has been floated for at least 50 years, and technically speaking, these are just up modified, so to say, submarine engines. So what the hell happened now? Here's the AI is the current hype. Now, if you're old enough, you must have seen multiple hypes come and go. Back in the old days, it was big data, then it became like quantum computer, then it goes. It's one of those things, it happens, it's almost cyclical at this point in time. So AI is going through that hype right now, and the boom is big, it's huge, meaning basically just few years ago, this sort of server cluster, as in like a rack, was not consuming that much power, like few kilowatts at 10 kilowatt maybe. Now these puppies are pushing 40, and some newer designs are touching 200. There are designs that are limited simply by the fact that it's so much heat that they actually have to dunk it in order to cool it. You cannot cool it by air. So the energy requirements of supercomputers that are dealing with this hypercluster requirements, they're going bonkersly high, like unnaturally high. For example, even if you think like, well, let's say Amazon Web Service, majority of its work is actually just data hoarding, so to say. Now again, it does have crunching and sort of like, even when you talk about Netflix just does not takes the file and dumps it to you. It takes the file and transcodes it many times real time, and then it gives it out. So you can understand that fundamentally there are a lot of processing going on, but AI is a whole different level. It just went from, oh, this data center was consuming like 200 300 megawatts to 1 gigawatt. What the hell? So let's just be very clear, the power drain is growing rapidly. And so basically, what is the requirement of the hour? Two things: boatload of power, bonkers large amount of water. And I have not seen that much discussion about the water, because I'm pretty sure once people understand how much water these things are wasting, yeah. And yes, the reason I'm calling it wasting, because there is an option. It just consumes a bit more electricity, but you will not waste water. And I am one of those guys who live in a water-stressed country. I'm not comfortable with wasting water. Wasting more energy, that's acceptable. But because again, in principle, you can get it out of solar and wind and renewable things. You cannot get water out of. So these two things are being consumed like there is no tomorrow. Now, power draw has grown exponentially rapidly, meaning this used to be a normal thing. Computers did not magically become a thing. There was a server, there was Google in 1990s. So it was a very simple thing. Slowly, brick by brick, it used to grow. So it was almost like natural power progression. We had 5 power plants, then we had 6 power plants, then we had 7 power. Like, it was naturally growing. It never was a scenario where it's like, oh, wait a minute, we have to lay a new coal-fired power plant just for this. That is first time happening with the computer ecosystem, so to say. So hyperclusters are reaching a point where each hypercluster can easily exceed 1 gigawatt. That's a lot of power. And be mindful that 1 gigawatt is brutal because it's constant. It's just like, it's not like, city consuming gigawatts of power where it's like, there is a bit of curve to it. There's like, it goes up, then comes down. It's like, no. It's dead load. So that's a very brutal thing. And there are many more under construction. So seriously large amount of money being poured in here. Now, government utilities, that's the first point to ask, right? Like, hey, I want to build it, you will go to government. It's like, hey, I need power. Now, they are willing to accommodate, but they are asking a much higher price. And, well, the higher price is not that big of a deal, is that they are asking for long-term power contract, that PPA, power purchasing agreement, so to say. Now, the reason is, you have to understand this way. As a consumer, we are a consumer from a utility company. There is power plant maker, there is a middleman, and then they sell the power to us. Cool, awesome, no problem. But when you're talking about something huge, let's say a cement plant or any industrial plant, there's a completely different argument, because again, you could be like, hey, I'm building this plant. This plant is going to consume 200 megawatt. Grid does not just have 200 megawatt. They actually have to do the calculation where it's like, okay, do we have that much spare capacity? Most of the time they will, sometimes they will not. And then they're like, okay, where is the nearest capacity that we can bring online or buy? Or like, okay, they will tell you, it's like, hey, you have to wait 6 months. This new coal power plant would be in commissioned. That way we can satisfy your needs. So there is a lot of things has to go. Now, because they have to do this much work and they have to basically do power purchase agreement with the producers, they will ask the same thing on you. Basically, they are passing the cost down to you. So you have to sign a very long-term agreement. For example, even the smallest PPAs are generally 10 years, 20 years. These are normal. So power purchasing agreement are like kind of brutal in this regard, that you have to not only like, hey, I'm building this unit and this will be here for next 10 years. Yeah, it has to be for next 10 years. You have to buy it, because again, they paid such an exorbitant amount. Companies are painful, like, not liking that part. They're okay with the high price. It's like, okay, it's higher, okay, no problem. But it gives them the flexibility. It's like, okay, if it eats itself after, let's say, 3 years, the hype calms down, okay, no problem. But again, if the power purchasing agreement is for, let's say, 20 years, you have to consume it. So PPA is kind of difficult. It's not as cut and dry as you would think. So many companies are like, I'm not sure about that 20-year part. And be mindful, what are we trying to do? What this whole company is trying to do is trying its best to reduce power consumption. Let's assume we did achieve that. Then what? Then it was like, yeah, we paid for 1 gigawatt or 10 gigawatt, and now we only need 1 gigawatt. That would be awkward conversation to have in a power purchase agreement. It's like, yeah, we kind of grew brain and we used brain, and then we realized that instead of using electronics, we should use photonics. And yeah, instead of running at gigahertz, now we run at terahertz, and it consumes far less power, but it's bigger. That's the penalty. Size is huge. Benefit, no power consumption, low, very low. So there is a reality to it. So they are not happy. So why didn't renewable, step up to the plate? Because again, recently that war of Russia-Ukraine, the whole reason EU did not just poofed itself is simply because renewables, like, I got you, fam. Like, you would be shocked how much renewable, like, I got you, fam. Like, especially wind farms, especially offshore wind farms. And you now will understand why the heck there is so much money being poured into offshore wind farm in EU. They learned it the hard way, that if you have good amount of it and large amount of it and spread out about it, you good. And that's why they are investing a bonkers amount of money in grid interconnects. So at this point in time, 2024, renewable is a proven technology. It's not if this then that. Right now, I can pick up a phone in India and call someone. It's like, hey, bro, we need a 2 gigawatt of solar farm. It's like, hey, where's your land? It's like, okay, this is the land. Okay, we can build it in 2 years. That's India. That's our past tense. That was our fastest record. We were building 1.5 megawatts of solar capacity per day in a farm. That's how good we were. And again, you can easily exceed this. It's not like miracle level thing. It's like normal. So it's a proven technology, quickly deployed, and it's a low cost. So in terms of how much money you are paying per megawatt, it's actually low. So that's there. That's sorted. However, let that be very clear. That's the plant side of thing. That is sorted. It does have two missing components. That's the reason why this was not the shining moment people wanted it to be. And again, it would have helped the whole planet exponentially, but it did not. It's simply because we had two missing components, especially in America. As you can see, lot of stuff here. That's the grid. Lot of sparse area. Awesome for solar and wind. Yeah, but sparse. There is no grid here. So that created a very serious problem. Grid interconnects are missing, and many projects have been put in limbo. Land acquisition is done. We are like, we ready to go, bro. We ready to go. It's just there is no grid there. And then like, okay, why don't they just build the grid? Yeah, it's expensive. And grid takes far longer to pay off compared to basically other system, because here's the deal. The grid, whenever somebody is thinking about, you would think about from your plant. Let's say you have solar farm, you send it to your small substation, then you high voltage it up to, let's say, 500 kV or something like that, send it to next substation. But here's the deal. After that, you will not not figure about that cost, because after that it's on the grid operator. Grid operator is like, okay, I got this let's say 2 gigawatt of extra power. Do I actually have links to dump that energy? Turns out no. Majority of the links are almost at max capacity. There is not enough spare capacity where you could just like read. So basically you have to build a new links from receiving substations. Like, okay, can we actually, or upgrade it? Like, let's say you had 500 kV, upgrade it to 800 kV if right of purchase is done already, as in like the land area for the power lines are sorted. It can be done. But you see, that's the whole point. Your grid is maxed out, because again, we built grid reverse order, meaning we have power, then we built the grid. So grid was already maxed out. So grid interconnects are expensive. It can be done, let that be very clear. It can be done. It just takes very long time. And that's another reason why governments are like, yeah, we need to charge you more. I was like, why? Yeah, even if the power plant is not that expensive, it's just that we have to build so much grid, which again will have much, longer time scale to pay off, that it's difficult. So that's one very serious weak link, where this part is like, so much energy is ready to go. It's just that they cannot absorb it, so to say. Now that's one missing link. Second missing link is that humanity's hulululu that is going on with that multi-gigawatt hour scale battery. I have no idea how the heck humanity will this face this problem, solve this problem in 1977, and we are still going round and round, dog chasing his tail. It's like at this point there is nothing. I cannot pick up a phone and give you anything other than pumped storage that can give you. It's like, I got you, fam. Gigawatt hour, I'm done. Like, it's in America, because again the photos are directly from America. It's there, it's built. It's not like new thing or could be or tested. 1977, before computers were a thing, we built this. It's working, tested, sorted. I'm not even joking. There is a whole session on Senate where you can see that they are talking. It's like, why the heck new plants are. I'm not saying this was the actual reaction where it's like we do not know. It's just stuck in bureaucracy. And people are like, what if we had this battery and all that? It's like, what if you did something that we have been doing? And these things have infinite lifespan. As long as you can maintain them, as long as you can repair them, basically like any infrastructure, this will keep running. So fundamentally, the battery part is unsorted. So solar can give you more than enough power. If you had the grid, then this will become the issue. And this is tragic. This is the reason why renewables are not growing. We are going round and round. What if this? What if that? Is like, that's not the problem. What if you had a grid? What if you had the people with brain is like, hey, we have this working technology, right? It works, right? We tested it, right? We have damage with this. We had issues with this. We sorted it. We figured it out. All of these things are sorted. Let's turbocharge this. 50, 60 of these, done, go home. That's it. Only 50, 60. It's not even 10,000. 50, 60, done, go home. So renewables, that's why renewables are not able to step up to the plate. So what about this SMR? So big players need a lot of power quickly. That's the whole point. Now all these people who are talking about making servers, they have deep pockets, like very deep pocket. Now what does the benefit of deep pocket is? Well, you can do what we call lubrication of bureaucracy, meaning you can get things done. For example, if a small company goes to a government office, it's like, hey, we need this approval and all that, that could take 5 years. Just the paperwork. And when these people with deep pocket goes, it's like, done. I want it yesterday. Sir, done, sir. Done. Government things move. So that's the good part of the, like, if they want it, they can get it done. So if people are like, hey, wouldn't the regulation will slow it down? Of course it will slow it down. But if these companies are no longer alone, they have people with very deep pocket, with who can pick up the phone call. Like in India, we have we are talking to ministers, like, hey, talk to this minister. Like, that's our flex. In America, it's like, talk to the senator. Or like in a small scale, it will like, talk to the mayor and all that. So these people have the ability to lubricate that paperwork process so they can get science going. They're like, bro, we got the regulation sorted. Okay. So fast tracking paperwork, that's a very big advantage. Like, you would be shocked how painful it is for small companies to just push through the paperwork. Another aspect is, what is this idea of small modular reactor? Inherently, it's divided in two parts. First part is the normal part, the coal power plant part, where you have turbines, generator, substation, the steam cycle, the condenser, radiator, and all that. So that's a normal thing. Copy paste from any brand, any corporation, no worry about that. But what about the heater part? Basically the nuclear heater, that is made into a smaller unit. So that smaller unit would be different designs. These are 3 designs that I'm showing you. Some have salt reactors. This design uses helium. I'll talk more about that. And this design has multiple salt loops. You have to understand this. You generally do not want the idea of water going through a reactor directly. The reason is nuclear reactions have this naughty particle known as neutrons, and neutrons hate everything, and they hate it so much that if you stop it, it will make you radioactive. For example, water. Water is like, I will not let neutron pass. Neutron is like, I will pass through you. Water is like, no, fam, you will stop. It's like, okay, here's my curse to you. You become radioactive. So if water is going through something that has neutron flux, it will become radioactive. Now, it's not water itself becoming radioactive, it's the element hydrogen in it that becomes radioactive. So you have to understand, many times you will see this sort of design, why they have loop and then they loop, then they have the water. The primary reason is you do not want water directly exposed to the neutron flux. Even if something contaminant is there, the likelihood of contamination making water radioactive is 0. You need neutron flux to make it. So running water directly through the reactor, then why do we do it? It's more efficient, but does come with a penalty that water is now radioactive. So the whole idea of nuclear heater, basically the hot part, so to say, radioactively hot part, is done in a small unit. And what if you need more power? No problem, you add more of this. You do not, turbine, generator, substation, all of those are completely different. Those are what we call standard part. Pick up a phone, call ABB, they got you. Or call Siemens if you want discount. So That's sorted. It's just that nuclear heater part, they are made small. Now, why making it small? Well, here's the deal. Many times the nuclear power plant designs, they're big, they're awesome. Problem is the cost is also idiotically awesome. And because it's so huge, it cannot be shipped properly. You cannot like, and again, the likelihood of you having the steel factory that is making the containment wall right there on the spot is zero. So you have to ship it. How would you ship it? You can't. You have to cut it in small pieces or forge it in small segments, move it there, then weld everything together. Now, all of these things on paper, nobody thinks about it. But if you figure out where the money is going, majority of the money is going in there. Just the paper. And again, God help you if any fault is detected. It's like, oh, we bought it and it's cracked. It's like, oops. So the idea with small modular reactor is that nuclear heating element will make it small. Penalty, it will become far more inefficient. Benefit, it will be built. It's like, okay, we build this stuff. Everything in the structure is actually shippable by road and train. They are designing it everything such a way that nothing is so brutally big or heavy or expensive that's like, very what we call bottleneck. Everything can be made. So they built a reactor vessel. Cool, awesome. It faced inspection. Let's say they did a neutron californium scan to it, and it's like, yeah, it's cracked. No problem, build a new one. It will not stop the whole project. It's like, that's the whole point. It's like, okay, we are building graphite moderator around it, and the graphite is not of the spec. No problem. It's not giant units of a truck size. It's like a small unit. You put it in CNC machine. Actually happened. Video available. So that's the whole point of it. Shrinking that nuclear hot part instead of taking 15 years to build. It's like, okay, we built it and we built it more. And then we keep building it. Then we mass produced it. That's the whole aim. The aim is to turbocharge that part. So yes, you will have to consume far more if you have the same design of reactor compared to a large unit rather than multiple small units. But multiple small units can be made, can be shipped, and can be added based on your requirements. So for example, this whole unit, they have figured it out, they made it, no problem. And it's like companies like, bro, I need around, let's say, 200 megawatt. They're like, okay, we are sending 4 of you. You know what? 5. One for like downtimes and all that. Cool, no problem. Then it's company like, bro, we need 10 gigawatt. Oh, no problem. We are sending more. That's the whole aim of it. The nuclear heater part is so small that it can actually be built on time. And because we are serious mass production of it, it's actually upgradable, it's actually refinable, and you will have a final product. Because the biggest problem with nuclear is that engineers tell you the timeline, which is a lol. So they'll tell you, we're going to build it in 7 years. Awesome. Call me up in 14 years. Not even joking. That's the hilarious part of all nuclear. Let that be clear. All nuclear power plants. So that's the whole point. And we have many designs, many designs. Some have salt, some have gas. Yes, I'm not joking. There is a design that has a gas as a coolant. So there are a lot of things that are under pressure. But that's the aim of it. Having small units that can actually be shipped, can actually be manufactured, and actually can be done rapidly enough where it's like, oh, 3 years from now, you'll have something. So aim is this should be fast enough to comparable to be a coal power plant, not a nuclear power plant. So what about the timeline? Now, timeline is none of this is real. Now, this is the idea that I was talking about. They're using helium. Why they're using helium? If you want to transfer heat from A to B, you generally want to use a light element gas. The best is hydrogen. For example, your power plant generator is cooled by hydrogen. It has a rotor. Rotor has waste heat, which is in lot of watts, as in kilowatts or sometimes in megawatts of heat. How would you conduct it? Well, water is awesome, but how would you touch it? Well, you can't. So they are like, okay, what if you have a sealed the generator, and inside that you have water radiators? Cool, but how you'll conduct that radiator to the rotor? You don't. You pressurize that place with pure hydrogen made on site. Pure hydrogen. That's how it's cooled. So hydrogen is awesome in that regard. But here's the why would not you want to do this here? Well, yeah, hydrogen will absorb a neutron and become radioactive, and you do not want that. So they are using helium. Bit less conduction efficiency, but it should be safer. So the idea is that helium will conduct the heat into water, and water will be safe. So that's the aim of it. However, at this point in time, I cannot figure out, or even again, factually have checked multiple places, but there is no single working small modular reactor that's like, this is a reactor, this is the utility company that is buying electricity from it. None of them. It's almost like fusion at this point in time. And that's the inherent design. They are trying to make it cheap rather than just small and powerful compared to a nuclear submarine reactors. And again, they do not want to use weapons grade boom powder. They want to use a normal grade. So X Energy, Jeff Bezos is like, I got you, fam. So X Energy is getting bonkers amount of money for that reason. Then you have Cryos Power by Google, they're getting bonkers amount of money for that. And then you have Terra Power, Bill Gates is directly paying money into that. So all of these are paying them. Now, what time can we expect it? Well, their over optimistic timeline is 2030s. Now, would that happen in 2030? Let that be very clear. That's only 6 years from now. So not only building a reactor and actually selling power, let that be clear, selling power from it in 6 years. Yeah. At this point in time, the best they have, I can see, is like, oh, they have a vessel. Nothing else is there. Like, nobody is like, okay, we have run it, like, at least for 1 hour or something. No, none of them. So likelihood of that is zero. And let me be very clear, if anybody showed a small modular reactor like this, yeah, that's a lol. You're not supposed to do that, because even if you on paper did all the calculations, like, okay, this much graphite should absorb all the neutron, you will never expose it. Like, this reactor core, so to say, the nuclear heating element, never supposed to be exposed. People should not be able to go around it. The whole idea is that you will always bury it in a well, so to say. That well will be shielded, double, triple shielded, to make sure that even in a worst case boom scenario or worst case meltdown scenario, it does not contaminate it. This reactor is transportable, but it's not on. I've seen many designs like, okay, military is going to carry it. It's like, yeah, they have to bury it for safety. We bury RTGs that we are carrying for lunar mission. You're not going to have an active neutron source just like lol. It's going to radioactify the whole truck. Like, why? Truck is made of steel, which is carbon. Carbon does not like neutron flux. So the timeline is long. Let that be very clear. That's the part, I think that's why somebody is like, are you actually sure that 6 years from now, the AI hype will be exactly the same level as it's right now? So 6 years from now, that's the aim. So yeah, but I did like the idea of having helium as a heat transportation rather than, any other thing. That was unique. So what are the risks here? Well, here's the you have to understand, fundamentally, almost everything goes through boom and bust like this. Car companies, we used to have hundreds of car companies. Now they are just, majority of them are brands. Apparently, there are 2.5 car companies in USA. Tell me which these companies are, and especially what is 0.5. But that's the whole point. And again, for India, the biggest recent experience was mobile carriers. We used to have so many. We used to have Vodafone, Idea, Docomo, I forgot many of them. During school time, that was all the rage back then. We had so many. Now there are only 3, and one of them is almost limping at this point in time. So it happens. And again, rocket company also. So many rocket company after SpaceX. Then there's like majority of them poofed. Now only 2, 3 are remaining. It's normal. This boom and bust cycle is almost normal. Like, it's supposed to happen. Like, oh, 5, 6 delivery companies came to be, and only 1, 2, 3 survived. It happens. Like 50, 60 companies try to have that, like, Ola kind of model, Uber kind of model, only 1 or 2 survived. It happens. It's one of those things. It's like boom and bust is almost cyclical. You have to understand it. It's not like, oh, this will not happen. No, it will happen. It's a guaranteed. Just question is when. Like and it's almost everything else also had this. Quantum computer. The reason why you're not hearing about quantum computers now is because people are reaching that ceiling point where it's like, yeah. And again, NFT. Do I have to go more about that? Hyperloop, same thing. And crypto, like, no, crypto is working, the, Bitcoin prices are high. Here's the deal. How many cryptos were created at their boom period? Millions of them. And thousands of them were big ones. FTX was huge, as in like huge, freaking huge. And what happened? Poof, same thing. So boom and bust happens in everything. Web 3.0, solar roadway, all of this is normal. Like, at this point in time, if you are not expecting this in any industry, you're done. Like, fundamentally, this is one of the absolute history of humanity. It's like everybody gets into it and then it just poofs. So, and another aspect, I have not seen that much discussion. Where will you get that much cheap fresh water? Like, where? Now, let that be very clear. There is an option. If you have surplus power, you can just run a proper air condition or 2-stage air condition to get far more efficiency. It's doable, but I have not seen that much interaction about it. And again, waste would be there forever. Now, let me clarify this forever part. Anything that exceeds human lifespan is classified as forever, because again, to you, it is forever. So if any Tom, Dick, and Harry is like, oh, the waste made out of thorium reactors or this sort of sodium designs and all that is not that bad. Yeah, is it exceeding a single human lifespan? Let's say a baby was born, the baby went poof after 120 years. Would that radiation would be there? Would that be classified as radiation hazard? Yes, then it is forever. We humans have minds that are hundreds of years old. These minds have been mined. We never bothered to seal them up properly, so now we have acid mine drainage, and these things are so toxic, so contaminating that they touch a river gets sterilized. We have oil wells. We drained oil out of it. They became low profitability, and then we forgot to seal them. We did not have money to seal them. You are telling me to my face that a species that cannot seal mines, that cannot seal basically oil wells, which mind you is not that expensive. YouTubers are doing it at this point in time, are gonna take care of basically this? Yeah, that's not happening. Let me be very clear. Science and engineering is sorted. Can we do this? Yes. Can we do this for hundreds of years? No. I'm not even touching 1,000. And let that be very clear. Everything that has been made is still there. It's not like the first reactors are like, oh, we shut down that reactor. It's like that does not make any difference at all. And God help you if those reactors were making dirty radiation. Yeah, you have to keep handling them forever. Forever. You are telling me the species that cannot handle mines, the species that cannot handle oil wells are gonna handle freaking nuclear waste? I mean, like, pass the joint, my man. I want to feel that high, man. I really need. Like, this is the, they have to go inside a mountain and hollow it out and then store it. And then somebody's like, what if we debury it? It's like, oh yeah, who's paying for that? Like, we are not paying for sealing these tubes. We are not paying for protecting our freaking rivers. And you're going to tell me that somebody is going to pay billions of dollars for this sort of infrastructures? Who is feeding this BS? Like, there are only two people who will think nuclear is a useful technology in human society. Scientist and engineer, because they are not normal people. Engineers never figure out how to cost effectively deploy anything. Cost is always a lot. Again, I do not hate them. That's the reality of it. The bridge is supposed to be for $5 million. Lol. The tunnel is supposed to be $2 million. Lol. The nuclear power plant should be built in 7 years. Lol. So, again, there's nothing not to it. It's a hard thing. That's the penalty of it. But again, I'm talking about humans. And again, because it's forever, as in you will be long poofed. And you, right now, let's say you are a powerful individual who has like authority and getting things done and you are managing all this. Cool. What after your death? And what after your, whoever you put in charge 2-3 generations from now? Yeah, this is BS. That's the whole point. 5-6 generations, that only gives you 200 years. That's not much. So this whole idea, like, let me be very clear. Nothing is inherently wrong with nuclear. Everything is inherently wrong with human, especially with our economics. And that's absolute reality. You will have a dictator going kaboom, boom, boom, then what? And again, it happens. So let me be very clear. It's nothing about science and engineering. It's everything about human civilization and human psychology. You have to work around it. You cannot force it. Oh, only if you were, yeah, only if you were gods. It's like, that's the same BS. It's like, this is who we are. We have to work around it. I am far more comfortable sleeping with the fact that, hey, we have solar farms. Oh, it has waste. I'm far more comfortable with that rather than, oh, we have nuclear waste that is sealed in concrete. We're like, yeah, it's going to last forever. Have you heard of this thing known as water? It's classified as universal solvent for a good reason. And the time scale these things have to be monitored. Yeah, if water leaks inside there, it's going to be like, bro, let me show you why I'm called universal solvent. Like, what if we encased in this? What if it that? It's like, yeah, who is paying for that? And be mindful, there is a competition now from renewable. Renewable is far more cheaper. I have 2 kilowatt of solar generator on my rooftop. I do not have a nuclear reactor. So there is a risk, and that risk is absolute. And I do understand it from the corporation's point of view. I did wish, like, companies are like, what if we just, right now is the moment somebody pushed for, like, pumped hydro. It's like, that would have solved so many problems. But again, I'm reasonably sure this will, like, there is a very good chance this burst happens before the reactors actually get deployed. It's like 2030, it's like, dang, humans with that much attention span? Have you heard of TikTok? So there is a risk. Let this be very clear. It's nothing wrong about the science. Everything is wrong about the human way of working. You have to work around it. We're not going to take care of it. You have to design. We do not need to take care of it. Or again, it should not be like it contaminates thousands of areas of hectare or underwater aquifer where it's like people are like, oh, why this whole town died? Yeah, water was contaminated. I do not want to hear that. And trust me, these sort of things have happened. Google it yourself. So this was my presentation on this whole new hype of small modular reactor. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me exercise appointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.